Bismillah, alhamdulillah, salatu wassalam ala rasulillah. Today, inshallah, we will continue section 5.1, which is about angle measures. Indeed, we have main objective section. Achieved the first two. In the standard position. This is, of course, related to one of the most important concepts in this section, which is the coterminal angles. Today, inshallah, we will focus more on the length of a circular arc and the circular motion, how to deal with these two mathematical and physical concepts at the same time. This, of course, the degree and the meridian measure. What I wanted to remember here that how we define the radian measure. The radian, the measure of angle in radians, it is what? It is the length of the arc that subtends the angle. Of course, when you have a circle with radius equals to 1, the theta that is here, it's the length of the arc corresponding to or subtends the angle. It is the same. So here, in this case, S is theta, theta is S. We will study today what will happen if the radius is not 1, when it is R, for example, in general. This will be space. How to convert from degrees to radians. Here you can from degrees to radian, from radian to degrees. Just be careful here whenever you have 1 in degrees, you have to write the circle at the top. Without, if just you said 1, it means 1 radian. When no unit is given, then the angle is assumed to be in radians. The angle is in standard position if its vertex is at the origin and the initial side is the positive x-axis. Of course, the terminal side could be anywhere. The direction could be positive in this way, direction this way. What is special about the coterminal angles? What are the coterminal angles? Like look at the angle here in A and the angle in C. Of course, all of these 4 angles, they have the same vertex, the same initial side. But the angles in A and C, they have also the same terminal side. They are coterminal. They are a company in terminal side. What happens exactly that the angle in C, if we call this theta, in fact, this is theta plus 360. So we have here another full rotation. So they are in fact diverge. The coterminal angles measures diverge by 360 degrees, 2 pi in the case of radians. How to find the coterminal angles? The idea is so easy: add or subtract 360 as many as needed. N here is an integer. Of course, when it is positive, you are adding. When n is negative, you are subtracting. In the case of radians, it is 2 by n. So you will add or subtract 2 pi, multiples of 2 pi, 2 pi, 4 pi, 6 pi, and so on. This was the last exercise that we have stopped at in the previous class. How to find the least positive angle. The least positive angle, of course, positive means that it is greater than 0. The least angle, it is, of course, less than 360, if, of course, the angle is greater than 360. Usually, we use this idea to find the quadrant of the angle. For example, I can ask you the same, but in another way. In quadrant is this one. So this one, this. To decide how to know. In fact, you need to cancel the additional rotations that you have until you have an angle that is in quadrant number 1 or 2 or 3 or 4, which is, of course, between 0 and 360 degrees. So to find the coterminal angle, that is the smaller one, the smaller positive angle with this, what you will do, you will subtract 360 1 time, 2 times, 3 times, as many as needed. So it is not enough to subtract it 1 time. So you will try to subtract it twice. So you will subtract 720 degrees. In fact, it is still negative. We want it to be least positive. So it is not enough. You need to subtract it or add it 3 times. So in 3 times 360, this is negative 800 degrees minus or plus 1080 degrees. You need to remember these 3 multiples of 360s. I think they are mostly the used one. And you may add also 360 more to have, of course, 1440. These are the form. I don't believe that you need more than this. If you need more than this, you can use division. As I told you, you can use the division, the idea if with positive angles, not with the negative. Forget about the negative angles. The idea of dividing is not working there. Now, what you have here, just add, you will get 0 minus 0, 200 degrees. So this is the least positive angle with negative 800. Now you can answer the question in which quadrant, because they are coterminal, so they have the same terminal side, so they all have the same quadrant. So this is 280 degrees. Here it is. So it is in fact the same here. This is the positive angle. The one that is negative, it was like this. It has one rotation, 2 rotations, 3 rotations, and it comes back here. So this is negative 800 degrees. And this is, of course, they are in quadrant number 4. 1270 degrees. Here it is a positive. So you need just to subtract now 360 as many as needed. 2 times is not enough. 3 times, I believe. So it will be 1270 degrees minus 1080 degrees, which is this time it will be 091 degrees. In which quadrant now? 1270. It is 190, which is in the 3rd quadrant. This is 190 degrees. In C and D, in C, let's start with C. In C, in fact, the angle is in degrees. No, it is not in degrees. In C, it is in radians. Radians. I know that some of you, they still prefer to convert radians to degrees and then find the coterminal. I don't agree with them, because you may use this at the beginning, but not always. Because in this course, as you will see in chapter 6 and chapter 7, and also in calculus 1, calculus 2, you don't need or work with degrees anymore. Radians. They are, of course, representing in terms of real numbers better than degrees. 51 pi over 2. Don't convert to degrees. All what you need to do, ask yourself, 15 pi over 2. Of course, it is greater than 0. It is positive. This is not the problem. Now, it is in fact greater than 2 pi, because 51 over 2 greater than 2. Now, what you need to do, you need to subtract 2 pi as many as needed. So it is not enough to subtract it 1 time, because it will be 51 minus 4. It's still huge. Maybe you need to subtract it 2 times or 3 times, or in fact, you need to subtract multiples of 2 pi, even multiples. 2 pi, when you multiply it by 1, this is 1 multiple, 2 multiples, 3, 4. Always, if you notice, the multiples of 2 pi are always even. So you are adding 2 pi, 4 pi, 6 pi, and 8 pi. So to find the closer even number to this, what you need to do, you need to think about 51. What is the number that is smaller than 51 and it is even? It is 50. But 50, if you divide it by 2 pi, 50 pi, if you divide it by 2 pi, you will get what? You will get 25. 25. If you, let's divide it by 2, the 25 pi. This is not multiple of 2 pi, because the multiples of 2 pi, all of them are even. So you will go to the next one, which is not 50. The smaller one after that, it is 48. So 48 over 2, it will be 24. This will give you, why we are dividing by 2, this is the 2 that we divide by. This means that you need to multiply by 24 pi. Why? Because when you multiply 2 by 24, you will get 48. So here we are. So this will be equals to 51 pi over 2. I'm talking about the coterminal. If we subtract this, we will subtract from this to find the coterminal 24 pi, which will be 51 pi minus 48 pi over 2. This is 3 pi over 2. Now, if you didn't subtract 24, for example, if you subtract 22 or 20, you will get an angle that is greater than 2 pi. If you subtract more, like 26, if you use 26, you will get a negative angle. So we want an angle that is greater than 0 and less than 2 pi. We want the coterminal to be between 0 and 2 pi, the smallest positive angle. Okay, so now how to know that this is, of course, ya shabab, clearly it is less than 2 pi. 3/2 is less than 2. So this is less than 2 pi. And you can, of course, know that this is, if you want to think about it in degrees, this is 3/2. So in fact, it is quadrantal angles. It is not in quadrant number 1 or 3 or 4. It is quadrantal. It is on the negative y-axis, equals to 270 degrees. Now for the last angle, 10, look at the difference between 10 degrees and 10. 10 without any unit mentioned, it is in fact radians. So 10 radians, in which quadrant it is? What is the least positive angle that is coterminal with 10? To know that, what you need to do, you need to approximate. You need to ask yourself, is 10 greater than 2 pi or less than 2 pi? It is, of course, greater than 0, but is it less than? Of course, it is not greater than. It is not less than. It is greater than. So we have here. Let's remember, what is pi? Pi, it is what? Pi, it is approximately 3.14. 2 pi will be approximately 6.28. Let's remember it will be easier for us to work with it like this. What is pi/2 in this case? 3/2 will be, divide this by 2, approximately this is what? 1.57. 3/2. 3/2, this is 0. This is pi/2, which is approximately 1.75. Pi, it is approximately 3.14. 3/2. These are good numbers, the approximation to remember. When you multiply pi/2 by 3, so you will get 3. It is approximately 4.7. And then 0 and 2 pi again, which is approximately 6.8 to 8. Now 10 is greater than 2 pi. Why? Because 2 pi is approximately 10.28. So 10 is greater than 6 point something. So it is greater. So what we will do, we will subtract 2 pi, and we will see if we still greater than 2 pi, we will subtract 4 pi. But look, when you subtract 10 minus 2 pi, this is approximately 10 minus what? Minus 6.28. This is 2 pi. So this is approximately what? This is approximately 3.72, right? So this is less than 2 pi. Of course, if you subtract 2 pi more, you will get a negative. We are looking for least positive. So this is 3.72. Now, if the question was in which quadrant 10 is, you can know, of course. This is 3.7. So if this is 3.14, it will be here. It will be in the third quadrant. 10 is in the third quadrant. It is between pi and 3/2. Now, the second part of this section is about the circular arc. Again, as I told you, when this is 1, we define the radian to be like this. When this is 1, S is equals to theta. They are the same. The length, the arc of the length here is the same as theta. But if the radius is r, not necessarily 1 in general, then the length of the arc that subtends the central angle theta, it is equals to theta r. Theta is in radians. Of course, this is what we use to define radians. Whenever you have this relation, theta is in radians, not in degrees. The arc of the length will be just the radius multiplied by the theta. You can, of course, from this find r by dividing by theta. You can find theta by dividing by r. How to find a nice way to recall or remember this formula? Because unfortunately, some of you they mix between this formula. Is it r equals to theta r equals to sr or s theta? In fact, it is easy. Just look here. What is alone here? It is s. What are together? R and theta. So this will help you to remember that S that is alone equals to R multiplied by theta. Let's take an example about that. Find the length of the arc of an arc of a circle. So this is S. We need to find what is S. With radius, this is R. R is 10. That subtends a central theta, a central angles of theta degrees. So theta is equals to 30 degrees. We have R equals to 10 meter. You cannot work, of course, S is R theta, but theta is in radians. Look. So what you need to do, you need to convert this to radians. How to convert from degrees to radians? Multiply by what? Pi over 180. This will give you pi over 6. Remember that 30 degrees, it is pi over 6. So just you multiply now pi 6 by what? By, so now S will be equals to us. S R theta. S equals to, let me write it here. S equals to R theta. It is R is 10 and theta is pi, pi over 6. This is 5 pi over 3. What is the units? Meter. The length, of course, here is in meter. We have another example here about the central angle theta in a circle is with radius 4 centimeters. We have R equals to 4. So it's subtended by an arc. So we have S here, length is 6 meters. Again, the same units. Be careful about the units. Find the measure of theta in radians. Of course, theta will be what? S over R. So it will be 6 over 4. It is 3 over 2 radian. Whenever this formula is applied, the value of theta must be in radians, not degrees. But you may have it in degrees at the end after converting. Like here, look, we have here S is 4 pi centimeter. It is important, guys, to convert the problem from word problem to a mathematical model. And this is one of the main learning outcomes of this course. So we have S equals to 4 pi over 3, subtends a central angle theta in a circle with diameter 12 centimeters. So the diameter is 12 centimeters. This means that the radius diameter is 2R. So the radius is 6 centimeters. Find the degree measure of theta. So we want theta, but in degrees, not in radians. So how to do that? We will apply the formula. Remember the tool that you have, the main tool that we have here, it is S equals to R theta. We have S. Look, we are lucky because the radius and the length of the arc, they have the same units. No need to convert units. So this is 4 pi over 3 equals to R. What is R? 6. Now we need to find theta. Theta in this case will be 4 pi divided by 6. So it will be multiplied by 1 over 6, which gives what? Over 2, it will be 3 over 2, it will be, so this is 2 pi over 9. Now this is in radian. You want to convert this to degrees. What you need to do? You will multiply by 180 degrees over pi. Pi will be cancelled with pi. 9 over 1, 9 is 1. 18 over 9 is 2. 0. 20, it is 40 degrees. You may think, guys, when you convert from radians to degrees, it is enough to think about pi just like this. 2 multiplied by 180 degrees over 9. This is enough. It will give you the cancellation here. Look, pi will be cancelled with pi. But of course, it is not always like that. Pi equals 180 degrees. So when you convert, you replace pi by 180 degrees. The last part of this section is about the circular motion. What is the circular motion and what is the difference between it and between the linear motion? Of course, when we talk about the usual motion, the linear motion, when you move or wherever an object that you have, it moves in a straight line. This is the usual motion that we have. But when we are moving on a circular path, like here, we have a point here on a circle that moves on the circular path like this. What do we have? We still have the usual speed, the usual velocity that we are going to call linear speed. The linear speed, as you know, it is the rate of change of the position with time, the rate of change of the distance with time. So when we are here at some at some time, after a while, we will be here, for example. So the position has been changed with time. So if we call this the length of this arc, if it is s in fact here is the distance over the time. This is the linear velocity. Usually we denote it by v or by nu. It is up to you. This is nu in Greek language, and this is v in English. The same, no problem. So we have here what? It is about the linear speed. It is about the rate of change of the position with time. It is about how fast the position of the point is changing. But when we have, what is the main difference between the circular motion and the linear motion? In the circular motion, not only the position will be changed, not only the distance traveled will be changed. There is something else also will be changed with time. What is it? If you look at it, theta. Theta here is not the same as theta here, is not the same as theta here. So there is something here will change with time. So the rate of change of the angle with time, we call it the angular speed. It is about the rate of changing of the angle with time. We will denote it by omega. Omega equals to theta over 2. Again, omega is a Greek letter. Theta over 2. Formally, we define them this way. If we have a point moves, this is so important to read this definition, guys, because this is how we define the linear speed and the angular speed. We use these terminologies and this vocabulary in the questions that we will give you. Suppose that a point moves along a circle of radius r, and the ray from the center of the circle to the point traverses theta radians in time. Let s equals to r theta, which is the formula that when we used, we have theta radians. Be the distance traveled, then the speed of the object. By the way, here we use the same terminology, speed or velocity. You know that the speed is the absolute value of the velocity. In our case, of course, they are identical in the circular motion, as we know that the speed is the distance per time, the velocity is the displacement per time. So the linear speed, it is s over t. The arc length, this is s over t, and the angular speed is theta t. Of course, theta is in radians. Omega, as I told you, is a Greek letter. Omega is radian per minute, per time, because here, this is theta radian per time. It could be second, minutes, hours, and so on. What I want you to notice here, that s, what is s? S is what? R theta over t. Now, what is theta over t? This is r. Theta over t, it is what? Omega. So we have this interesting relation between the two velocities, the two speeds. That the linear speed, it is just the angular speed multiplied by the radius of the circle that we are moving on. Very interesting, and we use this heavily in the questions. Let's take this example about a boy that he is rotating a stone in a 3 feet long sling or a rope that at a rate of 15 revolutions every 10 seconds. Find the angular speed, the angular and the linear velocities speeds in this time of the stone. Imagine that you are in the place of this boy, and you are rotating a stone at the end of this rope. So we have here what? We have this is the sling that we have. So when you rotate it this way, in fact, the length of the sling or the rope will be what? Will be the radius. So we have here r equals to 30 feet. Now, what is this? 15 revolutions every 10 seconds. So we have 15. Let's write it shortly like this: revolution per every, it means per 10 seconds. Okay. So, in fact, what is this? What we need? We need, the question is, what is omega? What is nu? What is omega? What is the v or nu? To do that, you know that V, it is S over T. To find S, you need R theta over T. To find omega, you need theta over T. In fact, you need to remember your tools. These 4 formulas that we have here are our main tools in this section. So you may need them. You need to think about these quantities and to find them. But let's focus on this. In fact, the main given point is here. 15 revolutions every 10 seconds. It means what? It means indeed 1.5 revolution per second. Every 1 second, he will do 1.5 revolution. And this represents what indeed? If you want to look at theta, what is theta? You may say, oh, okay, T is given, T is 10 seconds. What is theta? Theta is this 50 revolution, but 50 revolution, you know that one revolution equals to what? 360 degrees. Unfortunately, we don't have degrees when we have this formula. So it is radian. So it is 2 by radian. So keep this in mind, that one revolution is equals to 2 by radian. And always you will use this fact. So to write this in another way, we will write it this way. It will be 15. One revolution means 2 by radians. And let's have this as it is, 10. And here we have second. In fact, now this should remind you about something. What is the quantity that its unit is radian per second, radian per time? You remember? Radian per time, it is the angular speed. So this is omega, in fact. When you convert the revolutions to radians, then you will get omega. But this is not omega, by the way. If you write that this is omega, this is wrong. This is not omega. After writing the revolutions in radians, it is omega. So this is not omega, this is omega. You can simplify this, of course. This is what? 2 times 15. This is theta, by the way. For those who are looking for theta, this is theta. Theta, it is 30 by radian. For those who are looking for T, this is T, 10 seconds. But indeed, we don't need it. Look, 30 by over 10, it is 3 by radian per second. This is omega. We did find the angular speed. Now, how to find the linear speed? It is just R times omega. Look, nu, it is R times omega. So it is just R. What is R? 3 feet multiplied by omega, which is 3 by radian per second. Now this gives you what? 9 by what? What are the units? What will be the units of the linear speed? You know that it is distance per time, so it will be feet per second. Okay. Now the question is, where is radian here? Why we didn't write it here in this unit? In fact, whenever we have the unit of the distance, no need to mention the radian anymore, because in fact the radian, just we mention it here to indicate that the angle is not in degrees, it is in radian measure. Let me explain that in another way. Do you remember that S, it is equals to R theta? So let's say that this is feet, this is in feet, this is in radian. Okay, now what is theta? Theta will be S over R. So it will be feet for the units, it will be feet over feet, meter over meter, centimeter over centimeter. So it is in fact the theta, it is just a number here, but we use the radian or degrees just to mention that which measure we are using. So in fact, it is not a unit in the same sense that we have the length unit for other quantities. So in fact, you can think about it like physically, it is unitless. It is the measure. In fact, the radian and degrees, they are the measure themselves. It is not the unit of the measure. Okay. So when we are talking about theta alone, we should mention, is it radian or degrees? But when we have the measure of the length here in the problem, this of course will cover the units, and you, in the presence of feet, meter, centimeter, the radian has no job to do. This is one way. What we did is solution number one. Let me show you another solution, but this is the best, of course. What we did is the best solution. So what we did, we were having 15 revolutions per 10 seconds. We convert the revolution, one revolution, to 2 pi radians. And in that case, we obtained omega, the angular speed, radian per second. The linear speed will be r just multiplied by omega, as we did. This is usually we prefer to write it seconds. Now the another way is to use theta s r and theta and find everything. So you need to find theta first. This is theta that was here, 2 pi multiplied by 15. Then omega will be theta over 2. To find nu, the linear speed, it is s over time. You need to find s. S is r theta. Then divided by t. Divided by 10, you will get. But I believe that solution number one is much, much better. Again, I'd like to emphasize on these 4 formulas. You need to use them, recall them, because they are your tools to deal with such problems. Let's have another example with a man this time instead of a boy. We have a man here that he is riding a bicycle whose wheels are 26 inch in diameter. So this means that the radius is 13 inches. If the wheels rotate at 125 revolutions per minute, RPM, this is the one that we have on our cars. Find the speed in mile per hour at which he is traveling. Of course, from the units you can know what we want. We want the linear speed, distance over time. So the question is, what is the linear speed? We know that the linear speed, it is r multiplied by omega, the angular speed, the radius multiplied by the angular speed. So the question is, what is the angular speed? We can have it from the number of revolutions. We have 125 revolutions per minute. So every 1 minute, we have 125 revolutions. Now convert the revolutions. This is 125. One revolution means 2 pi radian over minute, per minute. So this is in fact 250 pi radian per minute. Now this is omega. All what you need to do, just multiply it by what? By r. The problem here that we have r 13 inches and omega is 250 pi radian per minute. And what we want the linear speed in what? In miles per hours. In fact, the good news that we will not ask you in the exams or in the quizzes about miles and feet to convert them. But of course, for hours and minutes, you know how to do that. For example, if you want to convert the omega, here it will be 250 pi radian. You will convert 1 minute. This is 1 minute. 1 minute, it will be 1 over 60 hours. So this is, you are done now with the hours. The question now is how to convert the inches, the 13 inches to what? To miles. You need to know in 1 mile how many inches. This is a huge number. In fact, when you have 1 mile, this is just for you, for your kind information, because you will be one day an engineer. So it is good to have an idea about these American units. Usually we use the metric system, ya shabab, for such problems. So 1 mile, in fact, it is 5,280 feet. And there is a unit between them, by the way, the yard unit, it is in between them. Now 1 foot is equal to 12 inches. So now you have inch, you convert it to feet, then you convert the feet to what? So this one, if you want to convert it, it will be 13 multiplied by 1 over 5,280 feet, and then the feet you will be convert them to what? To inches, or the inches to feet, and then the feet to miles. You have it here just for kind of information. Usually, if we give you such questions, we will use the metric system of units: meter, centimeter, millimeter, kilometer, and so on. As I told you, this is just for your kind of information to have an idea about such situations. Maybe some of you, inshallah, will continue in the US their study. This is the summary of this section. The main three concepts that you have here. Let's say how to convert. This is so basic. So the standard position, the coterminal, this is the first one. The how to find the coterminal, and of course the arc length and the circular motion. Three main ideas that you need to be aware about. There are many solved exercises here for you to practice. I'll skip them and leave them for you. It is so important for you to practice them. The last, at the end, let's try to solve this recitation exercise. I think it will be the last one. We don't have time to do more. So what do we have here? We have here each tire of a car has a radius of 40 centimeters. So we have R equals to 40 centimeters. If the tires are rotating at 500 revolutions per minute, 1 minute per 1 minute, find the speed of the car in kilometers per hour. So what we want the linear speed in what are the units? Kilometer per hour. So this is what we want. Now this is how we convert this word problem into mathematical model. Now we know that nu is equals to r omega. So all what we need to do is to find omega. And in fact, omega, we have it partially here. Omega equals to what? 500, 1 revolution, it is 2 pi radians. So when we convert the revolutions to radians, 1 complete rotation, it is 2 pi. Per minute, this is indeed what? 1000 by radian per minute. Don't forget pi. Now this is omega. Now what we want the linear speed, which will be r times omega. What is r? R is 40 centimeter multiplied by this. We can write this, guys, as 10 to the power 3 pi. Don't forget pi. Many of you they forget pi. So let's write pi here in a clear way to avoid finding this. Now we need to think now about the units. Unfortunately, we have here centimeter. We want it to be kilometer. We have here minute. We want it to be hours. So we need to convert the centimeters to kilometers. Do you remember the relationship between them? 1 kilometer is 1,000 meter, which can be written, of course, as 10 to the power 3 meter, just for scientific notation. Do you remember the scientific notation from MATH001? Now, 1 meter is what? 1 meter is 100 centimeters. So this will be what? 10 to the power 2 centimeter. So we can now 1 meter, it will be 10 to the power 5 centimeter. So this means that 1 centimeter is what? If you want to have 1 centimeter, you will divide by 10 to the power 5. You will get 10 to the power negative 5 kilometer. So 40, it will be times 10 to the power negative 5 kilometers times 10 to the power 3 pi radian. Now 1 minute, it is 1 minute. It is we need to convert it to hours. So 1 hour is 60 minutes. 1 minute will be 1 over 60 hours. So this is 1 over 60 hours. Be careful when you work with units. Now what we will have here, we will have 4 times 10 to the power, this is 10 to be to the power negative what? 4 times 10 to the power 3 pi times, this will be 1 over 60, it will be 60 here. And what we have at the end, kilometer per hour. As I told you, the radians, radian, when in the presence of the units of length, kilometer, meter, whatever, it has no job to do. So we don't need to write it because this is at the end speed, velocity. It is distance per time. Just we use radian to indicate that it is not in degrees, it is in radians. Now simplify, you will get what? 4 times 6, 24. Pi, don't forget pi. Now 10 to the power negative 4 multiplied by 10 to the power 3, it will be 10 to the power negative 1. And you have here 10, so it will be 10 to the power 0, which is of course 1. And we have it at the end, kilometers per hour. This is the speed of the car in kilometers per hour. Let's check our answer. That's it. We will stop here and see you inshallah next class. Thank you.